Hello and welcome to the Electrician's Hangout. I would really like to apologize to everybody for not making a tutorial lately. I've been very consumed with my new business, which is building websites. Actually, I'm having a lot of fun at it and starting to learn quite a bit, but that's not what this tutorial is about, so I don't want to ramble on about all of that stuff. Actually, I had one of the subscribers to the Electrician's Hangout YouTube channel asked me to do a video tutorial on installing multiple switches. I replied to him and told him basically it's really no different than installing one switch, with the distinct difference actually you're just installing multiple switches, but you're pretty much doing the same thing multiple times. You're not really changing a tactic. One thing I definitely want to put out there, when you, and this goes for switches or receptacles, because I had another subscriber ask me how many outlets can you put on one circuit, and then the other guy was asking me, well, if I put three switches together, how many circuits do I need? The answer to those types of questions is going to always come down to this: what do you intend on putting on that circuit? The type of load that circuit is going to carry pretty much determines the size of the circuit, the number of outlets or lights you're going to have on a circuit. All of those things are determined by how much power they're going to draw, because every circuit is only capable of delivering so much power. And on top of that, you really don't want to ever take a circuit and load it up to its 100% of its capacity. A good rule of thumb, just like I told the guys on the YouTube channel, 80%. And I just tell them it's a good rule of thumb because I don't want to get into the code part of it, because that could get a little complicated. Technically, it gets into how many conductors is within a cable or within a conduit. Depending on the number of conductors, your derating factor kind of like goes down. Like I believe 3 conductors is 80%, maybe 4. Then 5, it drops down even lower. So the more circuits you have, or the more conductors you have within a cable or conduit, you're going to draw more heat because of those circuits being together, and ultimately it's going to lower how much you can actually by code load that circuit up to capacity. But just listen to me and do what I tell you. Keep the rule of thumb, 80%. If it's a 15 amp circuit, you're looking at no more than 12 amps. If it's a 20 amp circuit, no more than 16 amps. As far as wattage goes, 15 amp circuit is 1500 watts, a 20 amp circuit is 2500 watts. And like I say, that's at 100%. You always want to keep it at 80%. So enough with that. I'm going to try to answer. And I apologize to the guy that asked me the question. Dwayne may have been his name, but I truly don't remember. I'm getting old and I got way too much going on. But what I did here for you guys, because along with the vague answer I gave you to the how many outlets to put on the circuit and how many lights, really there's always more than one way to skin a cat. So when it comes to wiring your lights, and please excuse how sloppy everything looks. I didn't have a lot of wire, and I kind of sort of had to mix and match and kind of make things work here so that I could show you guys what I need to show you. But what I did was I used 2 different techniques for wiring up the switches. And you may run into either technique, and it's good to have an idea of pretty much what you're looking at when you run across it. So without further ado, we'll run across it real quick. First, I'll show you how I have this mess of stuff tied together, and then I'll show you, you know, the actual wiring of it and my reason for wiring it at that particular way. First and foremost, we got our 110 volt, which starts here, okay? That 110 volt cable is coming up to this box, okay? Right here. A jumper comes from this box over to this box, which moves the 110 volts over to this box, okay? The 110 volts then comes from out of this box, as you can see here, and it goes over and it supplies an outlet. I threw an outlet in there just so you guys could see how something would look in the real world, possibly. Just one out of a million. So it comes, power comes from the panel, start from the beginning. Power starts from the panel here, comes up to this box, comes out of this box to this box, leaves this box, comes to the outlet here, comes out of the outlet. This time it comes to a switch box, okay? And that's where this circuit ends, at this switch box. Now, we're going to go over a couple of different ways of wiring a switch. First, we're going to start with the easy way. And I say it's the easy way because basically you come into a box with 110 volts, which is the bottom cable here. And whenever you have your home running a box like that, the wire is going up to your light, which is the top cable here. Basically all you're doing is splicing the neutral together, okay? You're giving the light a neutral from the 110 volts coming in, and the side of the switch that stays hot all the time, which is the power that comes in, and you have this, which what we call a switch leg, which goes back up to the light. If I was to turn the circuit on and flip this switch, we see that light goes on and off. And if I was to break the circuit here, obviously the light would go off, but because it's being fed from here, remember, from the panel to the first box, to the second box, to the outlet, to the switch. So if I broke the circuit anywhere along this point, this light would cease to work there. And I mean, it's really just that straightforward with this setup. The 110 volt come in. If you have one 110 volt cable coming in and the switch leg going out, there is only one way to wire it up, and this is that way. You just splice the two white wires together and put the two black wires on the switch. You know, it don't get no easier than that. That's one way of doing it. And like I say, I purposely did this side differently because now the 110 volts is not coming into the switch box. It's coming into the box that's going to be in the ceiling or wherever your light lives at. That's where the 110 volts is in this particular scenario. Now, one thing that's interesting about doing it this way is you end up having a white wire that's hot or is carrying 110 volts. Is not a neutral. You would never ever see a neutral on a switch, ever. So when you're talking to somebody and say, yeah, you put the neutral on the switches, if they say something like that, immediately walk away. Don't listen no more because they don't know what they're talking about. They leading you down the wrong path. When you see a white wire on a switch like this, it is not a neutral. The code allows us to do this, to use the white wire in a 2-wire cable assembly as a switch loop. It allows us to use it in the switch loop, and we actually don't even have to tape it. But if you're going to wire it this way, being a homeowner, I would highly suggest that you take a piece of black tape, red tape, put it around this wire, or blue. Just put it around the wire, wrap it around it so you know that this wire is hot. And if you were to come up to the box here, remember 110 volts comes out and comes up to this box first. What we have here pretty much is 110 volts. The white wire that goes down to the switch is getting tied to the circuit, or the hot wire here. And the reason that we do this is because if you think about it, all we have is a black and a white wire in this cable, okay? And when we come up to the light, we don't want to end up with two white wires on a light. We want to have a black and a white wire. And in order for that to happen, we need to send this white wire down to the switch as an energized conductor. When it gets switched, it is switching the black wire, which comes actually on this side here, if you trace it. When we switch it, the black wire is what's going to get turned on and off. Hence, that's what's going to get connected to the light. So by taking and splicing this white wire, and it's not a neutral anymore once we do this. It's a current carrying, well, a neutral is a current conductor, but this is it's now become part of the supply circuit. When we do this, it's not a neutral. So by doing this, we ensure that the switch leg coming back is black, so that we now have a black and a white wire on our light, so as not to confuse somebody that comes and goes to work on a light. Electricians know when they look in the switch box and they see this setup, they know what they're looking at. You know, you as a homeowner probably are not aware of that, and you get caught up in the whole color thing, because normally you look in the panel, you see the neutral on the neutral bar, and you come in and you see this switch with the white wire on it. You're like, man, that don't make sense. That's what the situation is there. When you have one wire coming into your now, in this particular situation, you do not have 110 volt cable coming into the switch box. Okay? In this particular situation, there are no neutrals in this box at all. So if you wanted to, say, run an outlet, and you opened up this box, and this is what you've seen when you opened up this box, you would not be able to run an outlet off this box because you have no neutral. Okay? We'll turn it on and you'll be able to see it work. It's really straightforward. It's not a lot to it. And I can show you guys that no matter what we do, the outlet will always remain energized, which is what should happen. We'll put our meter here, and as you can see, we have 122 volts. Turn all the lights off, we're going to still have 120 volts there, because that's the way it's supposed to work. You don't want to turn your... There are some situations where you may want to control your outlet from a switch. Normally, if you're going to do something like that, you are going to only want to do one part of the outlet. Maybe the bottom half you want to control with a switch, and the top half you may want to keep on all the time. And there's a lot of reasons that you want to split it like that. One of the biggest reasons is when we install our outlets, we have rules that we have to follow with spacing between outlets, and generally it's no more than 12 foot between outlets. And the reason for that is that most extension cords are 6 foot long. What the code says is measuring horizontally along the floor line, you must have an outlet measuring 6 foot horizontally on the floor line either way. So that means that if I took my tape measure and I walked up to this wall and just picked an arbitrary spot, and I went and stuck my tape measure out 6 foot this way, or this way, either one way or the other, I should be able to hit an outlet. And if you space your outlets out 12 foot apart, no matter where you go, one way or the other, even to your left or to your right, 6 foot away from that point, there should be an outlet. So that's what the code is saying when they tell you you should be able to measure 6 foot along the wall line and be able to hit an outlet. If you space them 12 foot apart, that's it. And that's one of the reasons why you don't want to switch both sides of an outlet, because that will throw off your outlet spacing. It's just it increases the amount of things you could use the outlet for. You know, it's kind of annoying if you have your alarm clock plugged into an outlet and you go and you make a mistake and hit the switch and it turns off your alarm clock and you don't wake up on time to go to work or something like that. You know, anything. So it's a lot of reasons why you would want to not switch the whole outlet. If you're going to switch the outlet, only switch one half of it, and maybe, you know, we'll do that in the future lesson. But hopefully this answered the guy's question who asked me that about the multiple switches. Again, like I said, the number of lights that you are capable of putting on a circuit is totally determined by the wattage of the lights and the number. You know, you only have so much power that you can extract from a circuit before you start to overload it or get to a point where it's going to trip the breaker. And if you get to that point, then you didn't went way past where you should be. Like I said, typically you want to keep that rule of thumb that I told you about, 80%. If it's a 20 amp circuit, whatever you're going to do with that circuit, you don't want it to add up to no more than 16 amps. If it's a 15 amp circuit, you don't want it to add up to no more than 12 amps. That way you always stay at 80% or less of the circuit's capacity, which is a very good rule of thumb, trust me. And if you're in a home, that's pretty much the only rule you have to remember when it comes to that. And that's without getting overly complicated with it. Trust me when I tell you it could get a lot more complicated. And there are situations in a house that you will probably never run into that would require you to alter your circuit calculations a little bit more. But for the most part, if you follow the 80% rule, if you remember what I told you here about the two different ways you may come across a single pole switch, you should be okay. It's not that complicated. What I'll do on the next video tutorial is because it takes a little bit of time to throw all this stuff together, what I'll do is I'll keep this the way it is, and we'll open all this stuff up and we'll go over maybe troubleshooting and trying and learn and teach you guys how to figure out which wire is going where and what it all means. So if you ever run into this situation where somebody wired it like this and you start taking everything apart and it's time to put it all back together and you forget what you done, you know, bam. I'll show you guys how to do that, how to take your meter, and you'll be able to determine which wires are going where and how it's supposed to get wired and so forth and so on. So I hope this was helpful and this answered the question that was asked. If not, just shoot me a message and we can talk backwards and forwards, and hopefully I'll be able to get it right the next time. But hopefully this answered the question. Basically, it's not a lot to it. It looks probably a lot more complicated than it is. It's not that complicated. Again, like I told you, the reason everything is all raggedy there is because I didn't have a lot of wire left over, and that's also a rule in the code book. You know, work shall be done in a neat and workmanlike manner. So, you know, something like this would be totally unacceptable. I didn't have enough wire to show you. If you look at some of the previous tutorials I did, you know, we've been reusing this stuff here a lot, so things are getting cut and getting made sure that I'm being cheap and I'm not going out and buying another roll of wire. You know, like I told you guys before, I really don't make anything for this. The reason I do this is to help folks. You know, somebody helped me when I went and built my deck, and from that point on, you know, that kind of blew me away to somebody actually take the time and teach people, you know, step by step how to do things like that, so that they don't have to spend a ton of money to pay somebody to come in and do it for them. You know, that touched me, and I figured, well, you know, I have a few skills. You know, I can teach a little bit of something. So this is my gift. So again, thanks for joining me. Don't forget to go visit the website. You know, you get a whole lot more training there when it comes to electrical theory and things of that nature. And just give me a shout out sometime and let me know what you guys think. Anyways, till the next time, I'll see you guys later. Peace out.